Okay, so let's talk about 5.5 irrigation methods. And so let's start with just a fact about fresh water. First of all, the largest human use of fresh water is for irrigation. We use about 70% of all fresh water on the planet to irrigate and grow our crops. So that's just a little fact for you that you should know. All right, so there are four types of irrigation that College Board says that you need to know. So we're going to start here with furrow irrigation and kind of work our way around these. So, furrow irrigation, as you can see from the picture, is when a trench is dug right alongside the crops and it's filled with water. This is the most easy and inexpensive method of irrigation, and the water seeps into the soil very slowly. However, this form of irrigation is the least efficient of all the other forms. It's about 66% efficient, so what that means is that 33% or about one third of the water is lost to runoff, where it just runs into another low-lying area, or it evaporates. And again, and another issue that you need to worry about with furrow irrigation is that you can actually waterlog the plants, which means the plants can end up with too much water, which can be a real problem. All right, we're going to move on then to flood irrigation. Flood irrigation is just like it sounds. It's when an entire field is flooded. This is very easy to do, but it disrupts the plants more than furrow irrigation. You also have to be careful, and this isn't a suitable form of irrigation for every single type of crop, only certain crops. And the reason being is that it can very easily waterlog or overwater the plants and cause the plants to drown. This type of irrigation is about 80% efficient, and about 20% of the water runs off and evaporates as well. All right, I'm going to get rid of my camera here so we can see the spray irrigation. Spray irrigation is what we most are proud with. It's what we're used to seeing when we think of irrigating crops. It's essentially like a sprinkler that we have in our yard or a sprinkler system that we have for our grass. This is when the ground or surface water is pumped into spray nozzles. It is much more efficient than furrow irrigation. Only about 25% or even less water is lost due to evaporation or runoff. And it is more expensive though, because it requires energy to operate the pumps that are pumping the water out of the ground or out of surface water. And also, it requires energy for the movement of sprinklers. So it is one of the more expensive, but it is fairly effective and efficient. And then lastly, the most efficient type of irrigation is drip irrigation. However, one drawback with drip irrigation is that it is very costly. A positive or a pro for this type of irrigation is that it is over 95% efficient. So only about 5% of the water is lost to runoff and evaporation. And how this works is there are basically holes, small holes that are in the hoses, and the small holes allow the water to just drip very slowly out of the hoses. This really avoids waterlogging the plants or drowning the plants, and it conserves a lot of water because it is such an efficient system. This system is used a lot in greenhouses, and obviously in farming situations where it can, effectively be used. All right, so waterlogging, I mentioned that term. So waterlogging, just to kind of show you in more detail, is when overwatering saturates the soil. When we saturate the soil, you can see here in this picture that we're basically filling in all of the pores or spaces between the soil particles. Um, this is unsaturated soil and compared to saturated soil. You can see that because there's so much water here, air cannot get into the soil that air allows oxygen to be taken in by the roots. So that can be a problem. And since that oxygen can't get in there, it actually stunts the growth of the plant or can actually kill whole entire areas of crop. So that's a very bad thing. A solution to this waterlogging is to use either drip irrigation, but we already talked about how expensive that is compared to the others. Or you can actually aerate the soil by poking holes or creating cores in the soil. You may have had your yard, your lawn aerated, where they come through with a machine and they pull out cores of dirt so that air can get into the soil. And that's actually very beneficial for the bacteria that live in the soil, as we learned when we did our soil unit. And here, let me get rid of this picture again. You can actually see what happens. Here's shallow roots. The soil's very compacted. This is before aeration. This is poking holes or cores into the soil. It allows for deeper roots and new root growth after that aeration occurs. Okay, another issue with irrigation is something that we call soil salinization. This is something that you need to know. Salinization is the process of salt building up in soil over time. Essentially, how this happens is groundwater that we use for irrigation just naturally has some salt in it because groundwater is mixed in with a lot of the bedrock, which may have things like limestone and different types of rock that actually have high concentrations of salt within the rock. And so this salt then builds up in the water. Then, when we irrigate, that water with the salt is sprayed onto the crops. The water will evaporate or get used up by the plant, and the salt is actually left behind. It's not used by the plant, it can't evaporate. So, over time, this salt will just continually build up. Layers of salt will build up, and it can actually reach toxic levels that creates an environment where the plant roots are being dehydrated, and then the growth will be prevented with the plant. So a solution to prevent soil salinization is again to use drips irrigation because it's so efficient. You don't have to use as much water, so therefore as much the higher amounts of salt won't be left behind. You can also aerate the soil. That needs to happen to keep the roots healthy, but then also flushing with fresh water. This is really handy in areas that get enough rain because the rain would actually wash the salt away. But if you're in an area like Arizona or parts of the United States that are much drier, or because of climate change, a lot of our areas are becoming more susceptible to droughts. We're not getting the rainwater that washes away that salt, so we're having soil salinization actually be a larger, more large scale problem. You can also periodically switch to a freshwater source instead of a groundwater source. The issue with this, though, is especially out west, where this is a real problem, they're using the Colorado River and they're actually draining. There's actually fights. Different municipalities are fighting over who's going to use the water. And so this is really like a tragedy of the commons where no one technically owns the water, and people are fighting over the water and using up or depleting that resource. So there are times when the Colorado River actually runs dry because of all the irrigation that needs to occur. Okay, so global human water use. So we've talked about needing humans need fresh water in order to survive. So where are we using all of this water? Well, there's three main areas that use a lot of water. The first being agriculture. And you can see from this pie chart that 70%, like I said earlier, of our water is used in for agricultural purposes. The next highest amount of water is used for industrial purposes. About 19% of water on the planet used for industrial uses, or water, I should say, water that we use is used for industrial purposes. And then lastly, of water that we use, it's for municipal purposes, and that's about 11% of our water is used for things like, flushing the toilet, taking a shower, drinking water, cooking, that sort of thing. So anyway, that's just an overview of how our water is used. And then let's talk about aquifers and groundwater because I've mentioned both. Groundwater is the water that's stored in the pore space of permeable rock and also sediment layers. And you can kind of see that here in this saturated zone. And then aquifers is usable groundwater that's deposited for humans in almost like underground rivers, as you can see here. And there's two different types of aquifers. There's unconfined aquifers and confined aquifers. And basically, these are determined by the way that they are recharged or replenished by rain, by precipitation. Unconfined aquifers recharge very quickly. So there's usually some sort of flowing water close to them that recharges them. And that makes unconfined aquifers very nice for human use. Confined aquifers recharge and they're usually used for more longer term water deposits. They recharge very, very slowly. And so there's usually some sort of layer of impermeable rock that makes them very difficult to get to. And so that's the difference between those confined and unconfined sources. And so, how do we deplete aquifers? Well, there's usually some sort of cone of depression that occurs. Let's talk about that first. And this happens when there's like over usage. This kind of refers back to that tragedy of the commons, where we have all of this water down below the surface, and we have somebody like, let's say, not to like necessarily badmouth farmers, but let's say that there's a large industrial farming operation that needs to use a lot of irrigation. So they're going to drill a really deep well, and they're going to use a lot of this water, and then we'll have homeowners that use, homeowners don't generally drill as far into the ground, so the wells aren't as deep for homeowners. But these industrial, agricultural, or just other uses have the money to drill very deep wells. And so if they use a lot of water, we create this cone of depression that lowers the water table. And now you can see the neighbors of this large industrial agricultural farm they're now depleted of their water source. And this can make people very angry because now they need to spend more money to drill a new well. And so this really, is a good example of tragedy of the commons. Okay, so your practice FRQ for 5.5, you're going to describe how soil salinization occurs and propose a solution to prevent or remediate soil salinization. You're going to identify one disadvantage of the solution you propose. And so when we come back together next time, we're going to be talking about 5.6 pest control methods. I'll see you guys in class.